the first gas law that we're going to talk about is called the ideal gas law, and it relates pressure, volume, number of moles, temperature, and then we have this constant value in it. So P is pressure, V is volume, N is number of moles, and T is temperature, which must be in Kelvin. Guys, you haven't been through this because you didn't take a test over gases last year. But believe me when I say, if you leave it in Celsius, you will get the wrong answer. You have to use Kelvin. It would depend. It could be carried through. It could be a terminal problem where nothing else depended on it. But anything where you're going to carry it to another part, and you will see this. So they'll even go as far as telling you to use your answer from part G, like in the next part, and then say if you didn't get an answer for G, use 250, which is nice. R, like I said, is a constant. It's called the universal gas constant. It is given to you in the data booklet, which you guys have access to on OneNote. And if you need it on paper 1, which is multiple choice, it will be given to you in the problem. So the unit that it's given to you in is joules per Kelvin mole. So remember we said units aren't going to be written as fractions. So if a unit would typically be in the denominator, it's just going to be written with a negative exponent. But that unit is not particularly helpful to us because we're dealing with pressure units. So we can restate that. We can restate a joule as a Pascal, PA, times a meter cubed. Okay, so here's where it gets fun. We don't often use meters cubed because it's a very big unit of volume. We typically work in the scale of decimeters cubed or centimeters cubed, smaller. So when you are using R, this is just something I would stick in my head. If you're going to use pascals for pressure, P, then your volume needs to be in meters cubed. Or you can use decimeters cubed for volume and kilopascal for pressure. We are going to land mostly here. But you're going to have to remember that. You have to be careful with units. Always be careful with units. Always. And then the last part is just some pressure conversions. So 1 atmosphere equals 101.3 kilopascals, which equals 760 torr, or 760 millimeters of mercury. All of these are equivalent, so you can just pick out what you need. So if you were going to go from atmospheres to torr, 1 atmosphere equals 760 torr.
So what is 1 atmosphere?
Pressure. These measure pressure.
Okay. I was like, there's only 1 atmosphere.
Okay, yes. So the unit of atmospheres is based on the atmospheric pressure around us. So the pressure that the gases around us all the time exert on us. And so 1 atmosphere of pressure is typically the atmospheric pressure at sea level without storms. So if you're at sea level and there's a hurricane, all bets are off. But under normal circumstances, the normal atmospheric pressure is 1 atmosphere at sea level. So first we're going to start with what is density. So density is mass divided by volume. And then we're going to take the ideal gas law, which is PV equals nRT. And we're going to examine N. So if I think about moles in, how can I get to that? I can take the mass of a substance divided by its molar mass. So we're going to substitute that in, the mass divided by molar mass for N. And so we get pressure times volume equals mass times R times temperature divided by molar mass. So do we see where we got that? Yes? Okay? And then we're going to rearrange to solve for molar mass. So we're going to get big M by itself. So multiply both sides by big M and divide both sides by P times V. So we get molar mass of a gas equals mass times R, universal gas constant, times T, temperature, divided by V, volume, times P, pressure. And then if we look at this right here, what do we have? Density. So in doing this and working this out, we have density. So in place of that mass over volume, we can replace density depending on what we have. If it's a question where they give us mass and volume, we would use this. If it's a problem with density, we would use this version. So IB doesn't really care that you can derive these. I mean, rearranging equations you have to be able to do. I'm fine with you just memorizing these equations. I'm an equation memorizer personally. Like, I mean, I know density, I know ideal gas law. It's easier for me personally to just go through and figure out the formula. But you can just memorize these. They may actually be in your data booklet, so that could be an entire lie that I'm weaving. Let me look. Let me look. Let me look. Now, on paper one, you don't have the data booklet. No, you have to do paper one. Silly. Silly, silly, silly. I do not see it on here, so. Well, if you, then you just memorize it. No, you get a fresh, clean data booklet when you take the test. I know. So hard, isn't it? So hard.
Test scoring will increase dramatically if you get given all the answers.
If you were given all the answers, that's probably true. The first one, if you'll look at this, in 1982, the IUPAC, the International Union of Pure and Applied Chemistry, changed standard pressure from 1 atmosphere to 100 kilopascals. Now, those two quantities are close together, but 1 atmosphere is equal to 101.3 kilopascals. So essentially what they did was just change. So standard pressure used to be 101.3 kilopascals, and they changed it to 100 kilopascals. So what I want you guys to do is to determine the molar volume of a gas at the old STP. The numbers don't. Well, they didn't ask me what they wanted it numbered. We need to get to organic before topic 11. That I know. Okay, so start with the ideal gas law. Equals nRT. And if we're solving for molar volume, what units is that? Or what variables? And V. So we want to solve for N over V. So how do we rearrange the equation to make it N over V? N over V equals yep. So what's the pressure? And the old, it's in atmospheres, but we need it in kilopascals. So 1 atmosphere is how many kilopascals? 1.3 kilopascals.
It's really weird because your N looks like a B, and then your B looks like an X or a Y.
That's not even, I mean, you know that's not even the worst of my handwriting.
I
Like,
know. It just it's like it don't- that's how I see N's. So when it has
yep. The old, previously, standard pressure was 1 atmosphere, which is equal to 101.3 kilopascals. We converted it. And then R, 0.3, right? What are the units for it, though? That's important. So let's scroll up. Scroll. We're going to use this one. Decimeter cubed times kilopascals over Kelvin times mole. So, decimeter cubed times kilopascals over Kelvin times. And then what's standard temperature? Kelvin. Let's cancel out the units. They cancel out. Kelvin, do they cancel? Here? Yes? What about kilopascals? What didn't cancel out? The moles and the decimeters cubed. So, and those are in the denominator. So how would I write them in the numerator? Okay. So what will the unit be?
because I bunched them together. Then I put the fraction like on the line, so then it was just like then and V. Then on that one, it's like super. Never mind. It's not like a
Okay, so equals, let's do 3 significant figures. 0.07. Can I just shift decimeters cubed over moles to the top? Okay. So there on the bottom, tell me what the unit will be. What unit is this 0.0447 in? Okay, right now, let me rewrite this. Right now, in 1 over cubed.
So then it would just be decimeters cubed terminal to the -1.
It would be
Decimeters to the negative.
0.47 moles over decimeters cubed. No. Why? And it's still recording. So 0.04 what's happening. As a conversion factor, I would write 1 decibel equals 7 moles. But previously, when I looked at, go away, little box. When I look at molar volume of a gas, it was 1 mole equals however many decimeters cubed. So how could I switch this to be 1 mole equals insert number decimeters? Divide what?
You divide both sides by 0.04.
Yep. So what do you get? Do it! Do the numbers! Recorded.
Do the number. I got the wrong batteries for my calculator, so I have to send.
That's fine. I still have class set of calculators. I'm just adding more things to clean.
Do they use the calculators?
They use their phones.
I mean, the phone one isn't bad.
What'd you get? 22 point. Good. Old ST, the molar volume of a gas. Nope, no negative there. Was 22.4 decimeters cubed. Is this still true? Yes. 1 mole of an ideal gas at 1 atmosphere of pressure and 0 degrees Celsius does occupy a volume of 22.4 decimeters cubed. What's changed is just what the IUPAC calls STP. So this is still true. It's just not what we typically refer to as STP, but it's still a true conversion factor. So we wanted to be 1. So we divided both sides by 0.0447. So we got 1 over 0.0447. That's where we got the 22.4.